Assalamualaikum and hi. What is the introduction of the project? The introduction of the project is the dataset comprise information on traffic accident, comprising details such as the time, location, weather, condition, vehicle type, and driver characteristic within each incident. The primary outcome variable is accident severity, which is the target variable, which is typically categorized into level like fatal, serious injury, minor injury, and property damage only. This data can be utilized to analyze accident trends, develop, develop predictive model, and inform road safety strategies. So, what's the problem? The problem statement is with their high human and financial consequences, traffic accident present, and serious threat to public health and safety. So the study aimed to determine the best model for predicting accident severity level, which is death, major injury, minor injury, and property damage alone by examining an extensive dataset of accident variables. After we know the problem statement, we should have the objective, which is this project aims to develop and evaluate predictive model for accident severity, which is the target variable, using such enterprise manner. The goal is to identify the best model among decision tree, logistic regression, and neural network in predicting the severity of traffic accident.
Data description. Variable for the first slide, we have four, which is day of week, junction detail, accident severity, and light conditions. Variable for the next slide is carriageway hazard, number of vehicles, road surface condition, road type, and last variable for the slide is vehicle type and number of casualties. The target variable is accident severity, and other than that is input. Except for this variable are reject. Data partition for train, which is to build up the model, is 55%. For validation, which is test performance models, is 45%. And for decision tree, we have 50 leaves. Logistic regression is a statistical modeling technique that is used for binary classification issues with two possible outcomes. In contrast to linear regressions, which predicts continuous value, logistic regressions the likelihood that given occurrence falls into a specific category. For this project, we use the method which is backward and stepwise.
Now let's jump to artificial neural network. The graph from the previous slide indicates the cumulative response graph, with x-axis as depth and y-axis as cumulative response. So what can we interpret from the graph? Firstly, the training and validation lines are close, suggesting the model is generalizing well across both datasets. Secondly, both datasets show an increasing trend with depth, indicating that the scoring or ranking system is capturing meaningful patterns. And lastly, minor differences between the two lines at certain depths suggest slight variations in model performance, but they converge well overall. Next, the graph from the previous slide indicates the cumulative graph. with x exists as depth and y exists as cumulative lift. So what can we interpret from the graph? When depth grows, the lift reduces, which is common as the model's capacity to distinguish between less pertinent data segments deteriorates. Secondly, consistent model performance is further demonstrated by the well-aligned train and validation lines. Lastly, small variations between the lines point to places where consistency might be enhanced by model adjustment, especially at early depths. Now we are on the final step, which is model comparison. In this step, we will compare all models to choose the best one. So from the output, we choose decision tree as the champion model, even though it has the highest average squared error value compared to all other models. We still consider it as the champion model since it has the lowest misclassification rate and it has the highest ROC index value compared to other models. The conclusion for our project. Our presentation concludes that the SaaS enterprise miner software can demonstrate the strengths and limitations of predictive modeling techniques, such as decision tree, logistic regression, and neural network. Additionally, we can identify the best model out of those three predictive models through the model comparison. This highlights that the SaaS enterprise miner is vital to ensure accurate and explainable decisions as this software builds models meaningfully. That's all from us. Thank you.